We begin by going over our code and logic used to run the plant watering system. We start in the main where our Arduino board pins and OLED screen are defined and our graph for our measured values are made. We then pass necessary variables into each of our graphing and water tasks and button listener. The event file listens for a button press to turn off the system. The water file uses conditional statements to compare measured moisture values with pre-measured values every second to determine when and when not to dispense water. The graph file measures moisture every second and stores the value into an array list, which plots a point onto the graph with its corresponding second. In this demo, you will see the system working in real time, pumping water and making a graph. The system uses a MOSFET, 9-volt battery, and water pump with vinyl tubing to pump water into the plant. It uses a moisture sensor to determine which state the sensor needs to go into, and an OLED screen to display the states to the user. By creating a testing class to test the values of the moisture sensor and the pump in various scenarios. Additionally, there was issues in the code when transferring pin data from the main class into the water class. To debug this issue, printline statements were added in the receiving class to see if the correct values from the main class were being transferred over. This deduced that incorrect values were being transferred over into the water class, which helped debug and solve the issue. CLO2 was met by using Formatter4J and Princeton Standard Library API to build the system. Princeton Standard Library was necessary for making and plotting the measured moisture data onto a graph. Formatter4J was a cornerstone in the project as the data could not have been measured if Formatter wasn't communicating the Java language to the Arduino Grove board. CLO3 was met storing all measured moisture sensor data onto an array list as a long type. We then use a for loop lasting the size of the array list to plot points on the graph matching the index to each element on the list to the corresponding second. CLO4 was met by using event listeners and conditional statements to drive the system into different states. First was the button listener that continually checked if the D6 button was pressed, and if it was, it would turn the system off. The conditional statements in the water class check the measured moisture in the soil and compare with previously measured moisture of the soil wet and dry. Conditional statements then use this measured moisture to determine if the system should be in a watering state or idle. CLO5 was met by using the abstraction object-oriented programming element. My code went from all classes existing in one file into the classes existing in various different files that work together. This allowed the code to be better organized and easier to debug and refine since all relevant lines of code were placed together in their own specified file.